The following talk focuses on how graph databases are optimal for spotting viral content to the actors producing it. And it's brought us to an engineering enthusiast with a lot of stories to tell. Combining 10 years of industry experience with 5 years as a university assistant professor, he is a mentor, author, and speaker, organizing workshops and hosting talks addressing a broad range of technologies. Ladies and gentlemen, please welcome Calin Constantinov.
Doi? Okay. So, congratulations for making it to the very last presentation of 2022's Big Data Week. We had 2 full days of knowledge, of sharing information and all that. And I think in order for it to be absolutely complete, we should also talk about graph databases. Because, graph databases are part of the NoSQL world, are definitely very important for processing large amounts of information, and are something that I particularly like. Now, after 2 years of being online, do you see me well? Can you hear me well? Is everything all okay? Yeah? Okay. So, yeah, my name is Calin, and I'm a Neo4j enthusiast. How many of you have heard about Neo4j, have worked with it? Okay, it's better than 4 years ago when I first talked about Neo4j at the Big Data Week in Bucharest. So yeah, that means that I'll have a lot of things to share with you guys. This is me. I've been working with Neo4j since 2013, I guess. It started off as a hobby, and then it turned out to be my PhD thesis. So I have a PhD in Neo4j. I'm one of the few people on the planet that have that. I'm not sure if that's a good thing or a bad thing, but yeah. As you can see written on my heart, I'm part of Endava right now. I'm a discipline lead, innovation community lead in Endava. And I am relatively well known in the Neo4j community, having spoken at various conferences regarding Neo4j. Now, you've probably saw this picture a million times, I guess. So what's the deal? We have a lot of data, that's clear, that seems to be connected in some way. And the main point of what we can do with that data is to actually identify the relationships between those data points. Even in this picture, there's a graph, basically, yeah? So the knowledge, insight, and wisdom part are actually graphs. And what you can see in the wisdom part is that you actually are looking for a path in that graph. So basically, we have already a bunch of data coming from social networks, from whatever. The main point is to actually have the technology that would enable us to find those paths between our data points. There's a flip side to that, of course. We now have things like fake news, like trolls, like whatever. So it's not only about proving things are true, but it's also about sometimes proving that things are false. Crowd manipulation is also happening on platforms such as Facebook or Twitter or whatever. So I guess it's very important for us to have the right processing tools for enabling data analysis fast. Yeah. So graph databases and Neo4j don't really do something that other technology don't already do. The main point is actually doing it fast. Yeah. Electricity is very expensive nowadays, so we don't want analysis to take a few days. We want things that can run in a couple of seconds. Because of that, over the last decade or so, we saw the increase in popularity of graph databases, and it's still going up. A lot of people are starting to understand why we're using it, why is it cool, and what are the main scenarios for using it. For me, it was my lack of love, let's call it so, for SQL databases. Back in the day, I worked for a recommendation engine, very complex one, that basically needed to do the recommendations overnight. They took a lot of time to compute. We had a lot of joins, full auto joins, blah, blah, blah joins, whatever. Were very hard to debug, were very hard to maintain, and they took a lot of time to actually execute. Because of that, as you can see, a lot of Fortune 100 companies are now experimenting with Neo4j. I see that in my day-to-day job. Right now, my job is also to help companies leverage the powers of graph. As you can see, there are a lot of domains, various domains that can leverage the power of graphs. Be it finance or hospitality, everybody can work with graphs for a specific reason. Now, what is a graph? Well, it's pretty easy, yeah? Nodes and edges. Um, I will get very technical and I'll say that it's a Turing complete machine. What that means is that you can basically represent everything with a graph. It's like 1 and zeros in the end, right? Every data model in the end can become a graph. On the other hand, even if you think about the way in which you do data modeling in the entity relationship way in SQL, you also start off with a graph in the end. Now, let's look over a comparison of how we would do things in a native graph database, and I'll explain what a native graph database is in a minute, versus a traditional SQL database. So, we'll model a simple social network. We'll have a table that just models friendship relationships between some guy and some other guy. We'll say that, hey, we have 1 million users, and every user has 50 friends. We'll get to a huge table, right? Where Alice is friends with Davina, Alice is friends with Charlie, and so on and so forth. And we also see the other relationship where Davina is friends with Alice, and so on and so forth, because friendship relations are bidirectional. And in order to leverage the power of an index both ways, we kind of need to duplicate that. When it comes to graphs, things start to look much more understandable. Each node has direct relationships with the friends that it has, right? So we have an edge that points to every people that I'm friends with. In a native graph database, that's actually a pointer. The fact that it's a pointer makes graph databases as fast as they are, because you actually are connected via pointers to the whole people that you would be connected with, instead of an SQL database. In case of the SQL database, even though they are called relational databases, at the very moment you do data modeling and put your data in a table, you actually lose the relationships. You only get the relationships back during query time, yeah, when you recreate them using foreign keys and joins and whatever. But while your data is stored in the table, there are no relationships there, even though it's called a relational database. That's not the case for a graph. Now, in terms of saying, okay, let's find who are my friends, who are my friends' friends, who are my friends' friends' friends, so on and so forth. For that 1 million people that each have 50 friends, you'll see that for a depth of 2, sorry, basically just my friends, it's almost the same when you're using MySQL and the graph database. When you go up to a third hop, fourth hop, fifth hop, and so on and so forth, the graph database definitely wins in terms of execution time. Why is that? So basically, imagine you're in a huge stadium. If I were to ask you who are the people sitting next to you, if I were in an SQL database, you'd have to go row by row to everybody and ask them, hey, are you sitting next to me? Are you sitting next to me? Are you sitting next to me? And that gets bigger as the stadium gets bigger, because I always have to go through the whole table. Okay, it might be indexed and so on and so forth, but I still need to go over the whole index of the whole table, and it gets bigger and bigger and bigger. When I'm in a graph database, I just get up, and I just see the people that are connected near me, because I have a direct connection to them, and I don't care how big the stadium is. It can be as big as it can be. That's why this is happening. And whenever your scenario entails more than 4, 5 hops or join relationships, my suggestion would be to look into something different than SQL. I'm not saying graph databases, but definitely do look into graph databases. Now, some very cool examples of Neo4j being applied in the real world. These are from a few years back. The older people in the room probably know what an eBay is. For the younger audience, that used to be a thing, a huge website back in the day. So they said, okay, we want to build a conversational AI chatbot, whatever. It was like 5 or 6 years ago. Everybody was doing chatbots over there. They said, okay, we want a very smart chatbot. I want to go at the chatbot and tell it, hey, I want to buy a pair of shoes for my wife. Because eBay already knew stuff about me, it could deduce a lot of things from that simple sentence. Shoes, okay, this guy wears this shoe size for his wife. His wife might be a female or might not, it's 2022, but probably it's a female. What else? He usually spends about 80 bucks on a pair of shoes. His preferred brands are that and that and that. He likes some certain whatever, other things. That's the part of the contextual chatbot that was represented in Neo4j. So you're in a chatbot scenario. Whatever I told you, you can do in any technology whatsoever. But the main point of a chatbot is for it to respond to my replies as fast as possible. If I had a chatbot that would reply back in an hour, I would probably not use it, right? So the main point for which Neo4j was the chosen technology behind this implementation was how fast it was able to deduce all those things in a knowledge graph. And of course, for a knowledge graph, a graph database is the best thing that you can do. Another cool example, again back in 2016 or something like that, a big news outlet in the US said, okay, there were some elections in the US back then, which people tend to think that were influenced by Russia. And they said, okay, let's do an analysis over Twitter. They took a big data set from Twitter, and they wanted to see how those trolls interacted. There are a few of them, the big bubbles there, that wrote a lot of content, while the other ones were the ones that were spreading the content, redistributing, commenting, sharing, what else, and so on and so forth. Basically, they were the ones that were giving credibility to the guys that were pumping a lot of fake news. When you say it like that, it's very clear that something did happen, and Twitter might or might have not intervened. And such an analysis was pretty easy to do with a tool like Neo4j. My last example, which I really like, is called the Panama Papers. There have been numerous other studies similar to the Panama Papers, which were all done by these guys here, which actually won a Pulitzer Prize for the whole investigation. Panama Papers was something that, okay, so a bunch of documents were found, real documents, paper documents. They were modeled in Neo4j, and that allowed the investigators to find these circles of money laundering, let's call it like that. Yeah? Certain football players were identified in the Panama Papers. So were prime ministers of various countries and so on and so forth. Again, a quick analysis which was possible because of Neo4j. Now, let me go to some of my own examples of working with Neo4j. At some point I said, okay, I want to take a snapshot of LinkedIn and put it into Neo4j just to see how things are looking on LinkedIn. So I got a bunch of profiles of people working in the IT industry. Intermission. At some point, as you remember, there were also LinkedIn stories. Do you remember that? You could post your stories on LinkedIn as well. Yeah? Talk about TikTok. Okay. And I got this cool dashboard, let's call it, of people working in the IT industry in a city in Romania. What that enabled me to do was to identify which were the most common skills of those people, which were the skills that were gathering the most endorsements. In the lower left-hand corner, those were people leaving from company 1 and going to company B. That allowed me to see which companies were bleeding talent, right? And which companies were dragging the greatest talent. You can do such an analysis over periods of time, and that would enable you to see how things are evolving for a certain company. You can look over the seniority of the people that are leaving and going to another company, and seeing that a certain company is losing a lot of talent that's senior, and they are just pulling in juniors, and so on and so forth. This analysis here enabled me to identify for each company which was the most common skill set of people getting employed to a certain company. Yeah, so basically what would be the ideal profile of a candidate working for company 4 or whatever. And that would allow me to headhunt exactly that kind of person. So if there are any recruiters in the room, I know that this might seem interesting to you. It definitely is for, for recruiting. But yeah, the whole idea started from a thing called light leakage of information.
There's nothing like the urge of competition.
I didn't do anything, sorry. Recruiters were listening. Yeah, so basically, a few years back, there was a guy that got employed to HP. And he updated his LinkedIn profile, stating that I'm working on a state-of-the-art cloud, blah, 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 something. Back then, nobody knew that HP was actually investing into cloud solutions. So that's a thing called light leakage of information. By the things that we post on LinkedIn, without even thinking about too much, we can actually tell a lot of things about a company. Similarly, going back to that image there, if I see that the company is employing a lot of people that are working in blockchain, that might mean that that company is starting to invest in some certain technology. And that might mean that if I want to invest myself in that technology, I might go on the stock exchange and buy shares in that company because they are employing people that have a great skill in a certain technology. I will let this one sink a bit. Social dilemma was already mentioned here. Yeah, that's also a thing. So all this data analysis can be used for good things, but they can also be used for bad things. 10 more seconds. Yeah. I hope I'll still have a Facebook when I finish with this one. Okay, now going back to an example of Facebook. I'm going to present some dashboards, and then I'll go into Neo4j so we can play with the data set a little bit. The data that you see here is a combination, it's real Facebook data. Don't let anybody that does GDPR know that. I gathered that before the Cambridge Analytica scandal, when you could get a lot of data from Facebook, and you know what happened. I mean, yeah. Yeah, and let's look a little bit over the things that I was able to find out. And imagine that I did this over a few nights. Imagine what Cambridge Analytica was able to do by having a lot of computational power and engineers. So, very simple example. When should I post in order for me to get the largest number of reactions, right? So, a distribution that you would probably expect. Yeah. During the morning commute, back in the day when you had the morning commute, people were staying in the bus and liking stuff and whatever. Then you are actually working for some reason, right? So drop in, yeah. Lunch breaks, working again. And then choosing between spending time with your family or spending time on LinkedIn, yeah? And similarly, I could see the same thing in terms of months, yeah? So you can basically spot every year what's the month when Easter is, because it can differ from year to year, right? When's the national holiday? When's the Christmas? When people get depressed and feel that they need to show how happy they are. The usual stuff that we all do, right? Then I can look over how popular I am, and yes, I'm very popular. It was a nice analysis where I can see things like, okay, for every like that I give, I receive 21 likes back. So that's how popular I am. And a lot of statistics like that, where for each thing that I do, I see how much things I get back. Because in social media, there's a lot of reciprocal stuff. Yeah, I like your things, you like my things. So those need to be discarded in some way, because those aren't really the influencers. The main point is to have a lot of followers, not to follow a lot of people, right? The same with LinkedIn, Twitter, Instagram, whatever. Yeah? Basically, this became my market, my global economy of things, where people spend just a like and receive 21 things back, so on and so forth. Out of that, I derived some metrics that will allow me to see how popular each guy is. And I had this analysis done. The bigger the bubble, the more influent you globally are. And yeah, I'm very influent. Then the thicker the edge, the more influence there is between two people. So this is just a simple snapshot. But what's interesting in this thing? You see that small guy there called AI? Globally, it doesn't mean that much. But he seems to be influencing me quite a lot. Yeah? Basically, that's who is influencing the influencers, right? Because an influencer is just getting the ball rolling. But usually he's not the actual source of that ball. Yeah? So such of an analysis can actually spot who are the origins of those fake news articles or whatever. Not only the ones that are actually contributing the most to spreading them. And last, I also was able to see, in terms of those relationships between me and my peers, to see how much things like mutual reactions, mutual comments, mutual tags are all accounted for when doing the computation. Okay. And yeah, okay, let's also look over this one. So I compare my metric with things like betweenness centrality, page rank, which were done using the Neo4j graph data science library. And I was able to see how far away my ranking of people is compared to these well-known rankings. The problem when doing such an analysis is that you don't really have ground truth information, right? So you don't know who is the right one, because there's no way to tell, hey, this is the most influent. Based on what? Everybody can be basing that on something different. But the main point was to see that I'm not far away from those metrics, because a completely far away result would probably mean that something is wrong, in my opinion. Okay, and now let's look over Neo4j. Young crowd, okay, young crowd. That's MC Hammer, okay, yeah. Okay, this thing here is called Neo4j. We're looking over a Facebook dataset right now. And this is how a data model for that dataset in Neo4j would look like. It's something that you would be used to. So, for instance, I have a user here, right? That user has a user feed. In that user feed, there are a lot of posts. Those posts have some reactions, might include some hashtags, were posted at a certain moment in time, have comments, so on and so forth. So things that you would expect in the data model that looks over social networks. Now, let's have a little bit of fun with this and look over how I would query data in Neo4j. So I have a bunch of queries here. I'm cheating. I won't write them all. But the main point is that there's a query language called Cypher. The first one is very complex because it does some general statistics. So basically, let me run it. And I'll just skip the explanation. But then we can run more simple ones and see if Cypher is easy to understand or not. Basically, what this one does was to compute all those global statistics of my dataset that I had included in the slides. So basically, my dataset included 20K posts, 200K post reactions, 30K comments, so on and so forth. And in my global economy, overall, I can see on average how much reactions a post receives or a comment receives or so on and so forth. And I can see, for instance, if a guy is far away or not from that average. Now, let's grab a random user from that dataset. Let's get a random user called Calin. Yeah, so how a Cypher query for that would look like. Match is the magic keyword in Cypher. Match user, that's a variable. The type of the variable is user, so node type is user, and the username is Calin. And I'm getting a nice bubble here, Calin. See some, so in Neo4j, each bubble, each node, is actually, also contains like a hash map of key property things. As you can see here, for that Calin node, also have Facebook ID and the Facebook ID. Gender, seems that I'm a male. Name, that's the name. The nice thing in Neo4j is that I can go over a node and click this magic button here, which will give me all the things that are related to Calin. Let me do a hack. Okay. So basically, I see a lot of reactions that are linked to Calin. And I can play with them and so on and so forth. And I can do that. I can continue doing that. I can go to this reaction and expand that thing. And then I can see that that reaction was linked to a reactions node here. I can expand that thing. And that will give me the whole things related to that, and so on and so forth. I can do a lot of easy data exploration with Neo4j that's easy for everybody in the room to understand, people of all walks of life, let's call it like that. It's visual, you can easily see, okay, so that's linked with that, that's linked with that, and so on and so forth. Now, let's do an analysis of how cool Calin is. So, right now, I'm getting a user Calin. Then for that user, the user has some posts in his user feed. I get up to the post. Post has some reactions. Those reactions were created by some other user, and those reactions have a type, like, love, pride, whatever type of reactions were there in the Facebook world back in the day. And whenever I do this, I easily spot the types of reactions that Calin is getting. So you can see that I have a lot of like reactions, loves not so much, haha, wow, sad, angry, so on and so forth. This type of analysis can give me a hint on how to account for, when doing a sum or an average or whatever, of the things that Calin has received, right? Maybe I would say, hey, love reactions aren't those that common. They might be weighted a little bit more than like reaction, so on and so forth. Then I want to see who are my biggest fans, right? So let's look a little bit here. So basically, again, I get the reactions, get the users that are posting the reactions, the type of that reactions, so on and so forth, and I'm doing a little bit of data anonymizing there. Basically, I can see that, for instance, my biggest fan seems to be somebody called Bada. Yeah. They gave me, because it should be gender neutral pronoun, right? They gave me 258 like reactions and so on and so forth. And I can scroll down and see that, hey, the second one is Razvan, that seems to be loving me a lot. Even a pride or two, yeah, stuff like that. So a type of analysis that you might not want to share with your significant other, right? In case you're not doing good things on Facebook. Then let's move forward with another type of analysis. I'm sure most of you want to see the same statistics for your own profiles, but yeah. Just give me all your data and I promise to. Okay, so basically this is the analysis that you saw earlier. The number of reactions that I received over my history on Facebook, that's how many I gave. That's how many I get for each one that I give. The number is a little bit different because in the other analysis I discarded the things that likes to things that I'm already tagged in or something like that. So you can do a lot of cool analysis and figure out who are the narcissists, who are the people liking their own posts, right? I also encountered interesting stuff like people that had 200 check-ins in the same location for some reason. Yeah. So a lot of interesting things that you can see. What else? Let me get some posts from myself, from my timeline. So for instance, for each post, I can see if there's a message associated with that or not. Maybe it's just a picture or whatever. So these are posts on my timeline. I can look over the ones that I've authored, or maybe they are on my timeline because I'm only tagged in them and they have been authored by someone else. And I can see the reaction types for all those things. Now for the last analysis, let's spend a little bit of time looking at this one. So very, very simple way in which to account for influence. So basically what I'm doing for all the things that are in my user feed, I'm looking over the comments, the replies to those comments, the reactions to the post, reactions to the comment, reaction to the reply, so on and so forth. And I'm assigning a power to all the things. So I'm saying, hey, the power of a post that is in my timeline is a sum of 5 times the number of comments. Let's say that the comment is the most valuable thing in my economy. 4 times the number of reactions, 3 times the number of replies, 2 times the number of comments, reactions, 1 time blah, 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 right? And that would allow me, by using this very simple analysis, to spot which are the most powerful posts in my timeline. I don't see any reason for me to be ashamed. My friends contributed to that being one of the powerful posts in my timeline. Yeah. And with this thought in mind, I am going to end it here. You can find me on LinkedIn, on GitHub, and let's hear some questions.
Any questions?
Hello. From my point of view, this was one of the best presentations from these 2 days.
Thank you. That's not a question, but thank you.
Also, I wanted to ask, I wasn't here from the beginning, so the data that you had, it's not on real time? From my understanding, you have just a database and you're just querying it with Neo4j?
So how I got this data was by using Facebook's Graph API. They had a Graph API REST back in the day. Now that have that REST API, which by using user's token, you can get data for that user. I have data sets that were gathered before the Cambridge Analytica scandal. What was the Cambridge Analytica scandal? When before Cambridge Analytica, there was a permission that a user could grant that would allow an attacker to get all the data for that user and also for all the friends of that user. What that meant is that it was enough for you to have a single person in your list that wanted to win an iPhone or wanted to see which Game of Thrones character they resemble, or whatever other stupid games there were back in the day. And all your data from your Facebook got to those attackers. That was the Cambridge Analytica scandal. Basically, I had 10 user tokens. I left my laptop running for a night, and in the morning I had complete information for 22,000 people, just with 10 tokens, because everything is very connected, you know, the small world problem, everybody's 5 hops away, blah, 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 yeah? I also have data sets that are have been gathered after that, and for that you would need a lot of tokens in order to get significant amounts of information. Because right now, things are much more restricted. So getting your hands on a real Facebook dataset nowadays isn't that easy. And there's also the GDPR part of it.
Okay, thank you.
Thank you very much for the presentation. I have a question. Do you have the, say, the strength of the relation between, let's say, pointers?
Yes, so basically, as I mentioned, every node can have attached to it a hash map of key properties. The same happens with relationships. So on each relationship, I can put key value things. That can be strength 5, name whatever. So since, I mean, I'm friends with somebody since yesterday. All those things can be attached to a relationship between two nodes.
Okay, thank you.
And then I can say, okay, strength is the thing that actually gives the thickness of that relationship.
Anyone else? That being said, thank you very much once again.